Good evening, and welcome to the Sleepy Professor. Tonight, we will drift slowly into the quiet world beneath our feet. A world that at first glance seems silent and simple, yet it holds more life, more memory, and more story than we might ever imagine. The hidden memory of soil. Before we begin our descent into this soft and secret landscape, I would love to know where in the world you are listening from. It's always a joy to see just how far these journeys wander. And if you find comfort in these gentle explorations, a small like and a kind subscription would mean so very much. To those who are already here, already supporting this corner of calm curiosity, thank you. You're the reason this quiet space continues to grow. And just one more small favour, I have a new channel, The Sleepy Geographer. You'll find a link in the description, should you wish to drift into new horizons. But don't worry, I will keep this space soft and soothing. Nothing here will tug too hard at your attention. If this story does happen to keep your mind awake, then at least you'll carry with you a handful of gentle facts, like little lanterns, to light the stillness of the night. So, for now, let your body rest. Settle in. Let your mind wander, like roots sinking slowly downward, and allow the story beneath the ground to slowly unfold. The soil beneath us is not only a surface to stand upon, it is a witness, a keeper of memory, a patient collector of moments, layering fragments of stone, specks of pollen, the faint traces of fire, and echoes of lives long gone. Each handful of soil is a small archive, a library without shelves, without pages. Yet every grain remembers something. Raindrops that fell thousands of years ago, footsteps of people whose names are forgotten, the breath of forests that no longer grow. Tonight we will walk through these memories. We will linger in the structure of soil, its quiet layers stacked like the pages of a diary. We will listen to the delicate clues it carries, the chemical whispers of ancient climates, the pollen of vanished groves, even fragments of DNA from creatures who no longer walk this earth. Soil holds human stories as well. Fields once farmed, earth blackened and enriched by civilizations who left no monuments but who changed the very ground itself. We will wander into the living networks, the invisible threads of fungi and microbes, endlessly weaving life together, and we will pause at the silent patience of seeds, asleep for centuries, waiting for the right moment to rise again. Soil does more than remember the past. It quietly shapes the present, and it softly whispers into the future. By the end of this journey, the ground beneath you may feel different. Less like something ordinary, more like an old friend, a companion who has been here all along, holding memories older than mountains, older than cities, older than us. The hidden memory of soil is not only science, it is the story of time itself, written in the earth's quiet hand. Beneath your feet lies one of the thinnest yet most important layers on the planet. Soil may look like nothing more than a dusting of brown and grey, the kind that clings to shoes and stains knees after a day in the garden. But it is far from simple. It is the skin of the earth, a fragile covering that stretches over the continents. Compared to the vast height of mountains, or the deep heart of the earth, soil is astonishingly thin, just a few feet before the bedrock begins. And yet, within this shallow veil, there is a whole world, a world teeming with life, chemistry, and memory. Without soil, the land would be bare stone, silent, unable to hold the forests, the fields, the villages and cities that root themselves upon it. Soil begins as rock, ancient and unyielding. Over endless spans of time, mountains crumble beneath rain, wind and ice. Roots pry into stone. Invisible microbes nibble away at minerals. Pebbles are worn to sand, and sand is ground to dust. This is weathering, a process so slow it feels like the breathing of the planet itself. It can take hundreds, sometimes thousands of years for a single inch of rich soil to form. The earth beneath you today may have begun its quiet work long before the first seeds of agriculture were sown, long before the first cities rose. And soil is never just mineral. It is filled with traces of life, fallen leaves, the soft collapse of wood, the tiny remains of insects, the unseen threads of fungi, even the quiet return of animals to the ground. All of these mingle with the minerals, darkening into fertile earth, capable of holding new life. Soil is recycling in its truest form. It takes what has lived and gently folds it back into the cycle, making it the foundation for what will live next. It is both cradle and grave, a circle of endings that quietly become beginnings. To sense how alive soil really is, imagine holding just a teaspoon of it from a healthy meadow. So small, you could balance it on your fingertip. Yet within that tiny scoop, there could be billions of organisms. Bacteria, archaea, fungi, along with microscopic animals and the fine threads of roots. In fact, there are more living beings in a handful of soil than there are people on the entire planet. Most are invisible to the naked eye, and yet together they build an underground city vast and intricate. Some of them break down fallen leaves, returning nutrients to the earth. Some fix nitrogen from the air, transforming it into food that plants can use. Some form networks that connect the roots of trees, allowing whole forests to whisper to one another, sharing nutrients, even warnings, like families reaching out in the dark. Soil is not just alive. It is busy. It is bustling. It hums with activity on a scale almost too great to imagine. The structure of soil plays a vital role in this hidden liveliness. Rather than being a flat and uniform dust, soil is arranged in tiny clusters called aggregates. Little mineral grains bound together by organic matter and by the glues created by microbes. These small clusters leave behind spaces, minute gaps where air can drift and water can seep. In these spaces, roots can breathe, water can move, and microorganisms can thrive. Good soil is not heavy or hard packed. It is open, porous, full of structure, a careful balance of solids and emptiness. Too much sand, and water slips away too quickly. Too much clay, and the earth becomes suffocating and heavy. But the healthiest soils strike a delicate balance, supporting life both above and below the surface. When scientists classify soil, they look at texture, chemistry, and biology. Sandy soils drain quickly, but they lose nutrients with ease. Clay soils hold minerals, yet they resist roots and feel dense beneath the hand. Loam, the mixture of sand, silt, clay, and generous organic matter, is often considered ideal, especially for farming. Beyond texture, soils differ in acidity, in mineral richness, in how much carbon they can hold. Every variation creates its own habitat, shaping what plants can grow there, what animals can thrive. And soil is never static. It breathes. It exchanges gases with the air. It cycles nutrients, passing them from one form to another. It absorbs rain, holding it like a sponge, then releasing it slowly, softening both flood and drought. It holds carbon in its organic matter, quietly helping to balance the atmosphere. It even produces its own fragrance. The familiar earthy scent after rainfall comes from a compound released by soil-dwelling bacteria. That grounding aroma is a reminder of the hidden life beneath our feet. Humans have leaned on soil since the first seeds were sown. The earliest farmers settled in river valleys, where annual floods refreshed the ground, turning fields fertile. Civilizations rose where soil was generous, and fell when the earth was stripped or exhausted. Even now, more than 90% of our food depends on soil. Without it, human life on land would not exist. And yet, soil is fragile. It can be washed away by water, blown away by wind, stripped by deforestation, or drained by over-farming. Because it takes centuries to form, the loss of soil is not easily healed. This is why soil scientists often speak of it as a non-dot renewable resource, at least on human timescales. Stone may endure, forests may grow again, but once the thin skin of soil is gone, recovery is achingly slow. Beyond its practical importance, soil carries something quietly poetic. It is both humble and profound. We brush it from our boots without a thought, yet it is the very matter that holds ecosystems together. To walk across a field is to tread on an unseen universe, ceaselessly working, endlessly alive. Thinking of soil as the skin of the earth helps us imagine its living role. Like skin, it protects, it breathes, it senses, and it heals. It carries scars of past fires, marks of growth, and traces of memory. To see soil as mere dirt is to miss its vitality, its history, its community. Soil is not just what lies beneath. It is a community, a process, a record of time. It is an interface between rock and life shaped across millennia, alive with countless beings. It is the thin and precious skin of the planet, quietly sustaining everything above it. To appreciate soil is to appreciate the balance that allows life on Earth at all. And when seen this way, even the most ordinary patch of ground becomes extraordinary. A reminder that beneath our feet lies a world that is both fragile and infinite. When you look at a patch of earth, perhaps all you see is surface, grass, stones, bare ground. But if you were to look deeper, to cut down into the soil, you would begin to see a story layered beneath. Soil is not uniform all the way through. It arranges itself into horizons, bands of earth, each with its own color, its own texture, its own quiet character. To a trained eye, these layers are like pages in a book. Each horizon whispers a different part of the land's history. The very top of the soil is the freshest page. This is the organic horizon, a dark, loose layer rich with decomposed leaves, fallen roots, and the tiny remains of countless small lives. Sometimes it is called the litter layer, because it looks like a scattering of what the forest or the meadow has let go. Here, decomposition is at its busiest. Fungi spread their threads through rotting wood. Bacteria quietly transform fragments into nutrients. Earthworms churn and tunnel, leaving the soil soft and crumbly. This is where seeds awaken, roots begin their search, and life takes its first steps into the cycle again. Beneath lies the topsoil, the horizon most of us think of when we imagine soil. It is dark, fertile, and buzzing with invisible life. This is the horizon, a mingling of minerals from below and organic matter from above. Because plants root here, and because countless microbes and small creatures live within it, this horizon is essential for farming, for gardens, for the food that sustains us. Its loss, through erosion or exhaustion, has ended harvests and even civilizations. The fate of this thin layer has shaped human history more than we often realize. If you keep digging, the soil changes. The next layer, the horizon, is lighter in color, more barren, sometimes sandy. It is called the leaching layer because rainwater passes through it, carrying minerals downward. What remains is pale, depleted, a reminder of how water quietly reshapes the land. Not all soils have this layer, but where it exists, it tells of the long, slow movement of nutrients over time. Below it rests the horizon, the subsoil. Here the minerals carried from above begin to collect. Iron, clay, salts, all settling into bands. In some places, the colours are striking: rusty reds, warm yellows, deep browns, the signature of iron meeting oxygen deep in the earth. Though it holds less organic matter than the fertile topsoil, the subsoil is a quiet reservoir. It stores water, holds nutrients, and offers strength for the roots of trees that must reach deeper than the surface can provide. Deeper still lies the sea horizon. This is the place between soil and stone. Fragments of bedrock, half-dot weathered, half-dot whole. A foundation in transition, slowly breaking down under the long patience of time. There is little life here, but it is from this layer that new soil is born. And at the bottom, silent and unmoving, rests the horizon, solid bedrock. The parent stone, the ultimate source material from which every handful of soil has slowly been created. Together, these horizons form a profile, stacked and distinct, like chapters in a hidden book. A soil scientist, reading these layers, can learn how water has moved through the land, what plants once grew, what climates once lingered over centuries. To the untrained eye, the differences may seem subtle, but once you know to look, the soil reveals its story in shade and in texture. The colours themselves are a kind of language. Dark browns and blacks speak of richness, the presence of organic matter. Pale greys or whites tell of minerals leached away, washed downward by rain. Reds and yellows signal iron oxides, proof of how oxygen and water have left their mark. Sometimes, even hints of blue appear, soils that have sat waterlogged, where oxygen cannot easily reach. The texture, too, carries meaning. Soil made mostly of sand feels loose and grainy, draining quickly, leaving plants thirsty. Clay feels heavy, smooth between the fingers, able to hold water but slow to release it, sometimes suffocating roots. Silt is something in between, fine and soft, smooth as flour when rubbed between fingertips. And loam, the gentle mixture of all three, enriched with organic matter, is often thought of as the perfect balance, holding water, draining well, and offering a home for life to flourish. To touch soil, to crumble it in your hand, is to read a story of minerals, of water, of memory. Every handful is a fragment of the planet's diary, a page torn from the Earth's long and patient book, and with each grain we begin to understand its history. Was this land shaped by glaciers grinding stone into fine powder? Was it shaped by rivers that spread sand and silt in their wandering paths? Each texture is a clue, each grain a fragment of a larger narrative. Beyond colour and texture, soil horizons preserve evidence of events. A thin layer of charcoal may whisper of an ancient fire. A sudden sheet of sand might reveal a forgotten flood. Bands of ash recall the silence after a volcanic eruption. Even subtle changes in colour and texture can mark centuries of farming or grazing. To dig into the soil profile is to peel back time. Not just the present, not only what grows today, but stories that unfolded thousands of years ago, and with every layer comes a reminder of fragility. The top few inches, the fertile horizon that sustains most of terrestrial life, can vanish in a single storm if left bare. Once stripped away, it takes centuries to return. Beneath our feet is not just dirt, but a precious library, one that erosion can erase far faster than the earth can rewrite it. No two soil profiles are ever the same. The ground beneath a rainforest looks nothing like the soil of a desert or of a tundra. In the tropics, heavy rain washes nutrients quickly, leaving thick but surprisingly poor soils. In cold northern landscapes, decomposition slows to a crawl and dark organic layers accumulate, rich and fertile. In grasslands, endless cycles of growth and decay create some of the deepest, most generous topsoils on Earth. Each ecosystem writes its own version of the story. Each profile is a unique fingerprint of climate, vegetation, and time. If soil is the Earth's skin, then horizons are its wrinkles, its scars, its freckles, visible marks of time's passage. They remind us that beneath every step lies the quiet work of countless forces, the slow grinding of rock into dust, the ceaseless labor of organisms recycling life, the gentle persistence of water, dissolving and carrying minerals through the ground. To the casual eye, the profile may look ordinary, but under closer attention it becomes a diary written patiently by the earth itself. Thinking of soil in this layered way can shift our perspective. What once seemed flat and featureless becomes a stack of living history. Just as a book is far more than its cover, soil is far more than its surface. Its horizons invite us to pause, to dig a little deeper, and to discover that the land beneath us holds far more than we first imagined. If soil is the Earth's diary, then dust and sediments are the notes it has scribbled about the weather. The ground does not only remember what has lived and died, it remembers the skies. Every drought, every flood, every shift in wind or rain leaves chemical traces in the soil, quiet fingerprints of climates that shaped whole landscapes. By learning to read these clues, scientists can reconstruct the moods of the atmosphere stretching back thousands, even millions of years. When rain falls, it is not just water seeping into the ground. Raindrops carry dissolved gases, tiny minerals, faint signatures of the air. Over centuries, these patterns build up, leaving chemical markers that hold the memory of climate. For instance, the ratio of oxygen isotopes inside soil minerals can reveal whether the world was warm or cool when they formed. A heavier balance of oxygen .18 often signals colder conditions. It is like finding a thermometer hidden inside the very crystals of the earth. Dust too plays its part. Carried by winds across continents, fine particles drift and settle, sometimes traveling thousands of miles before they rest. Layers of wind-blown dust, called loess, build up in places such as northern China or the American Midwest. Each layer is like a frozen breath of time, capturing the dryness, the winds, the sparseness of vegetation during past ice ages. Dustier layers usually mean drier, harsher climates, when vegetation was sparse and winds swept unhindered across empty ground. But one of the most remarkable things about dust in soil is its reach. It does not always tell only of the local story. Because dust can travel halfway around the world, a single handful of soil may hold fragments from deserts, from volcanic eruptions, from distant mountains. Soil becomes an interconnected archive, a patchwork record of the planet as a whole. It is as though Earth has been writing postcards to itself, tiny messages carried by wind and rain, delivered quietly into the ground, waiting patiently for us to uncover them. Even the local dirt beneath our feet holds clues. The chemistry of soil remembers the balance of rain and drought. In dry regions, when water evaporates faster than it falls, salts are left behind. Over long ages, they can build into pale, crusted layers of calcium carbonate. These white bands, called caliche, are quiet markers of parched skies and thirsty years. By contrast, wetter times tend to wash minerals downward, leaving other chemical signatures behind. The balance of these minerals, layer by layer, tells the story of shifting skies, of abundance, of scarcity, of all the and between. Volcanoes leave their signature as well. When they erupt, clouds of ash drift across the land, settling into the soil in dark, unmistakable bands. These layers can be dated with precision, serving as timestamps within the earth. A single seam of ash may reveal not only the eruption itself, but the way that event cooled the skies, altered the rains, and touched life for years afterward. In frozen regions, permafrost soils cradle bubbles of ancient air, tiny spheres of atmosphere, sealed away for thousands of years. When scientists release and study these gases, they glimpse levels of carbon dioxide and methane long before human instruments ever existed. Permafrost is not just frozen ground, it is a time capsule of the planet's breath. Even deserts remember. In the Sahara, buried soils whisper of a time when the land was green, dotted with lakes and threaded with rivers. Fossil pollen from grasses and trees still rests in those layers, alongside the chemical traces of wetter days. The contrast with today's arid sands could not be greater, yet the memory endures tucked safely beneath the surface. The science of reading these memories is called paleopaetology, the study of ancient soils. Paleontologists are detectives of deep time. They polish thin slices of soil, examine them beneath microscopes, trace their chemistry, measure their isotopes. With these tools, they reconstruct climates tens of thousands, even hundreds of millions of years old. By stitching together soil records from across the world, they map the rise and fall of ice ages, the greening and drying of continents, the ebb and flow of monsoons across millennia. One of the most extraordinary archives lies in the Losas Plateau of northern China. Here, winds have piled up thick blankets of dust, hundreds of meters deep. Layer upon layer, alternating between pale lows and darker soils, preserves a nearly unbroken climate record, stretching back several million years. The pale layers speak of cold, dry, windy ice ages. The darker soils recall warmer, wetter interludes when vegetation flourished. The plateau is like a vast natural library, its pages stretching back to the dawn of humanity. Closer to our own time, soils have recorded more recent scars. The Dust Bowl of the 1930s left behind distinct layers of wind-blown silt across North America. These soils still bear the imprint of that decade, an era of drought and overfarming, of storms that blotted out the sun. It is a sobering reminder that soil remembers not only natural rhythms but also human choices. Reading the climates of the past in soil is not merely an academic exercise. It is a way of seeing forward. By understanding how soils captured ancient droughts, floods, and shifts in warmth, scientists can better anticipate the patterns of change unfolding now. The soil, in its quiet way, is a teacher. It shows how life responded before we had instruments or records, offering lessons for what may come next. And there is poetry in this too. Dust, so often brushed away as nuisance, turns out to be memory itself. Every gust of wind, every drop of rain, every season's turning leaves a trace, and the soil gathers those traces patiently. It becomes a memory bank for the atmosphere, a silent witness to the endless dance between earth and sky. Stand on a patch of ground, and you may see only grass beneath your feet, only clouds overhead. Yet under the surface lies a layered record of storms and droughts, of seasons long vanished, of skies the world has forgotten. To hold even a handful of soil is to hold not just the land, but the very breath of the past. In its chemistry, in its sediments, in its quiet depths, the soil carries the memory of the sky, and it remembers more than weather. It remembers plants, forests, grasses, crops that once clothed the land. Scattered invisibly through the soil are tiny survivors, grains of pollen, each lighter than dust yet tougher than stone. On spring days, pollen drifts in clouds, settling on windows, tickling noses, vanishing with the breeze. It feels fleeting, but many grains endure. They settle into soils, lakes and sediments, where they can rest for tens of thousands of years. What makes them so enduring is their outer wall, built of a material called sporopollenin. This strange, resilient polymer resists decay, fire, and even chemical attack. Leaves crumble, wood rots, bones dissolve, but pollen remains, like indestructible beads scattered across the ages. And every plant species makes its own design, Some pollen grains are smooth and round, others covered in spines or ridges, marked with pores or delicate ornament. Under the microscope, each grain is a signature, a name written in miniature. Imagine a lake at the edge of a forest. Every year, as trees release pollen, some of it drifts down, landing on the water's surface. It sinks and settles. Layer by layer, century after century, the grains accumulate in the sediment. By drawing a thin core from the lake bed, scientists can peel back this history, a millimeter at a time, traveling backward through the centuries. At the deepest levels, they might find spruce and pine, evidence of a cold ice age world. Above that, oak and hazel appear, marking a warmer period when broadleaf forests spread. Closer to the surface, grasses and cereals emerge, signals of human hands clearing woodlands and planting fields. The pollen is a diary, charting the entire ecological journey of a place. This work, known as palynology, the study of pollen, has revolutionized our understanding of past environments. In northern Europe, cores from bogs and lakes reveal forests marching back after the last ice age. First birch and pine, hardy pioneers that crept across the tundra. Then oak, elm and lime, flourishing in warmer centuries. And finally, the sharp signatures of cereals, a whisper of farming, followed by the steady decline of tree pollen as people cleared the land. The soil remembered it all, natural forests, human ploughs, the balance shifting between wilderness and cultivation. Beyond Europe, pollen records reach into the rise and fall of civilizations. In Central America, sediments preserve the pulse of the Maya world. There is maize pollen in abundance, a clear signal of agriculture, and alongside it the thinning trace of trees as forests fell. Then, after the Maya declined, the pollen shifts again, the trees reclaiming the land, green returning where fields once lay bare. The story of this civilization is written not only in ruined temples, but in pollen. The soil remembers not just the stones, but the living cover of the land, the plants that clothed it and fed its people. Soil may look silent, but on a microscopic level, it hums with fragments of stories far older than any living witness. Every creature that has walked the earth, from towering mammoths to grasses bending in the wind, has left behind a trail of molecules. Skin cells, hairs, bits of bone, fragments of roots, even the droppings of insects. All of these carry DNA, the genetic script of life. And in many places, those fragments fall into the soil, where they remain long after the body itself has vanished. This is called environmental DNA, or eDNA. It is as though the earth has been collecting signatures, invisible autographs pressed into its surface. Even when bones have dissolved, when wood has rotted, when no fossil remains, the soil still remembers. In a cave in Siberia, for example, scientists found DNA in the soil that revealed Neanderthals had once lived there, though no bones were left behind. In Arctic permafrost, DNA fragments have identified animals that roamed more than 10,000 years ago: mammoths, woolly rhinoceroses, reindeer. The creatures themselves are long gone, but their genetic echoes persist, hidden in the frozen ground. Unlike pollen, which can be seen under a microscope, eDNA is invisible. It must be coaxed out of the soil, carefully extracted and sequenced, letter by letter, to reveal the species it once belonged to. When analyzed, it becomes a chorus of voices. Not just one plant or one animal, but entire communities preserved together. A patch of tundra soil might whisper of lichens, mosses, hares, and owls. A scoop of lake mud might carry the memory of fish, reeds, insects, and the mammals that once drank from its edge. What makes this so extraordinary is how democratic it is. Fossils tend to preserve the large and the lucky, the mammoth caught in tar, the tree petrified in stone. But DNA in soil remembers the small and the fragile as well. The grasses, the microbes, the insects, the overlooked. It records not just spectacular moments, but ordinary lives, the everyday background of ancient ecosystems. And like pollen, eDNA connects past with present. The soil beneath our feet today is quietly absorbing DNA from everything around it. Plants shedding roots, birds leaving feathers, humans leaving traces with every step. Some of it will vanish quickly, but some of it will endure, caught in the Earth's protective layers, waiting for future eyes and future tools to read. There is something almost dreamlike in this, that a grain of soil may hold the ghost of a mammoth's passing, that a smear of cave earth can reveal who once sat by its fire, that beneath a meadow's surface lies not only the memory of the plants that still grow there, but the genetic whispers of species long gone. Soil is not simply alive, it is a library of life itself. Each pollen grain is an ink mark, each fragment of DNA a line of script, each horizon a page in a book written slowly, patiently, without end. To crumble a handful of soil in your palm is to hold not just the present landscape, but entire histories pressed into dust. For scientists, this means dirt is not just a jumble of minerals and organic matter. It is a vast molecular archive, a filing system for life that sometimes stretches back tens of thousands of years. DNA, deoxyribonucleic acid, is the instruction manual of life coiled into every cell. Normally, when an organism dies, DNA unravels quickly under the assault of sunlight, water, and microbes. Yet, under the right conditions, cold, dry, and dark, it can linger. Fragments become trapped in mineral surfaces, tucked into tiny pores of clay, or locked within frozen ground. There, shielded from decay, they may survive for astonishing spans of time. These fragments are rarely whole genomes, but they do not need to be. Even a few broken strands are enough to reveal what once walked, crawled, or rooted in a place. This evidence is known as environmental DNA, or eDNA. Unlike fossils, which demand bones or shells, eDNA can be left behind by something as small as a footprint, a tuft of fur, or the falling of a single leaf. It is as though every organism signs the guestbook of the soil, even if its visit was brief. Modern sequencing allows scientists to gather these scattered fragments and piece them back together, reconstructing vanished environments without a single fossil in sight. One of the most dramatic demonstrations came from the permafrost of Siberia and Canada. From just a handful of frozen soil, researchers have recovered DNA of mammoths, woolly rhinoceroses, and giant steppe bison. Even when bones had long since dissolved, their genetic whispers remained, waiting in the frozen dark. With only a few grams of earth, entire Ice Age ecosystems could be glimpsed again. It is astonishing to think that a pinch of soil can hold the memory of a vanished world. Plants, too, leave their genetic signatures. Grasslands that disappeared thousands of years ago still speak through fragments of chloroplast DNA. Forests long cut down are remembered in traces of roots and leaves. Even aquatic plants can be identified in the sediments of dry lake beds. These traces reveal how landscapes shifted with ice and warmth, with drought and rain, with the hand of human cultivation. And beneath it all, microbes leave a steady rain of DNA. Tiny, unseen, yet abundant beyond measure. Their sequences tell of ancient lineages, of bacteria and archaea that once thrived in strange environments. Through them, scientists glimpse how microbial communities evolved, how they cycled nutrients, and how they shaped the earliest ecosystems. The archive reaches into human history as well. At archaeological sites, soil DNA has revealed the presence of people long after their bones had crumbled to nothing. A hearth, a footprint, a campsite. These small traces carry genetic echoes of those who once lived there, sometimes alongside the DNA of their crops and animals. It is as if the soil itself remembers not only the monuments of stone, but the everyday presence of life. The work of reading soil DNA is delicate. Scientists extract samples and coax the fragile strands free, amplifying them through a method called polymerase chain reaction, making enough copies to read. Sequencing machines then compare the fragments to vast databases of known species. The process is like piecing together a shredded manuscript. Individual words may be broken, but with enough fragments, the story becomes clear. Yet there is always the risk of contamination. Because DNA is everywhere, on the air, on tools, in the breath of those who handle it, laboratories take extreme precautions. Clean rooms, sterile gowns, filtered air. The irony is sharp. Soil may cradle the memory of a mammoth for 10,000 years, yet the careless sneeze of a researcher could overwrite the page. The insights gained are not only about the distant past. In the present, eDNA helps conservationists track rare and elusive species. A few strands in the soil may confirm the presence of a shy frog, a vanishing carnivore, or an invasive plant creeping into new ground. In this way, soil's genetic memory becomes a tool for protecting the life of today. There is something quietly poetic about this hidden archive. A mammoth, trudging across a snowy plain, could not have known that the cells it shed would be read by humans thousands of years later. A flower dropping its petals into the dust could not have imagined that fragments of its DNA would serve as proof of a climate warmer than today. Soil does not forget. It simply waits for someone patient enough to read its code. The durability of this archive humbles us. Human memory reaches back only a few generations. Written history covers mere thousands of years, but soil DNA stretches into epochs when ice sheets cloaked continents, and when forests grew where deserts now sprawl. To hold a vial of ancient permafrost soil is to hold not just dirt, but a census of a lost world. And yet, this record is fragile. DNA does degrade. Much has already been lost. What survives is partial, fragmentary, like a book missing whole chapters. But even these scattered pages enrich our understanding of the past. Enough lingers for us to glimpse, however faintly, what came before. Soil is not simply alive. It is something greater, something deeper. It is a library of life itself, a vast, patient archive that has been quietly gathering stories since long before any human eye ever looked upon it. Every pollen grain is like an ink mark. Every fragment of DNA is like a line of script. Every horizon of soil is like a page in a book, written slowly, gently, patiently, without haste and without end. To crumble a handful of soil in your palm is to hold not just dirt, not just minerals or dust, but an entire anthology of landscapes pressed into silence. In that dust are voices of forests that rose and fell, of rivers that wandered and then dried, of creatures that walked the earth and vanished into memory. For scientists, this means soil is not just a loose jumble of organic matter and stone. It is a molecular archive, a filing system of extraordinary breadth. It holds whispers of life that reach back tens of thousands of years, sometimes even more. DNA, deoxyribonucleic acid, is the instruction manual of life coiled and folded into every cell. Normally, when an organism dies, DNA does not last. Sunlight breaks it. Water dissolves it. Microbes chew it into nothing. And yet, under the right conditions, conditions of cold, of darkness, of dryness, the code lingers. Fragments nestle into mineral surfaces. They slip into the narrowest pores of clay. They become sheltered within frozen ground. And there, hidden, they wait. Complete genomes are rarely preserved, but fragments are enough. A single thread of code can reveal what species once roamed a valley, grazed a meadow, or anchored a forest. This evidence is called environmental DNA, or eDNA for short. Unlike fossils, which demand bones, shells, or imprints, eDNA requires only the faintest trace: a footprint pressed into mud, a tuft of fur caught on the wind, a fallen leaf slowly unraveling in the rain. It is as if every organism signs the guestbook of the soil, leaving its name in invisible script, even if its visit was brief. Modern sequencing now allows scientists to gather these fragments and reassemble them, piece by piece, into stories of entire vanished ecosystems. One of the most dramatic examples comes from the frozen permafrost of Siberia and Canada. From mere handfuls of ancient earth, researchers have recovered DNA of mammoths, woolly rhinoceroses, and giant steppe bison. The bones of these creatures have long since disappeared, but their genetic echoes linger in the soil. From a pinch of frozen dirt, whole Ice Age landscapes can be glimpsed again: cold grasslands stretching to the horizon, herds moving slowly across snow, predators shadowing them beneath a pale sky. It is astonishing, almost dreamlike, to think that soil can hold the memory of entire worlds. Plants, too, sign their names in soil DNA. Grasslands that vanished millennia ago can still be identified. Forests long since cut down are still remembered in the fragments of roots and leaves. Even aquatic plants, now gone from dried lake beds, remain in sedimentary whispers. These traces allow scientists to trace the shifting dance of ecosystems as glaciers advanced, as they retreated, as climates warmed, as humans arrived with fire and plough. And beneath it all, microbes add their ceaseless contribution. They are small, invisible to the naked eye, yet their abundance outnumbers everything else. Every moment they shed DNA into the soil. Ancient lineages of bacteria and archaea, once thriving in strange extreme environments, still speak through these sequences. Through them, scientists see the shaping of nutrient cycles, the silent labor of microbes building and breaking the world long before forests and animals filled it. This molecular memory does not end with the wild. It reaches into human history. At archaeological sites, soil DNA has revealed the presence of people who left no bones behind. A hearth, a cave floor, a forgotten campsite, all hold fragments of human presence, sometimes mixed with the DNA of animals they kept, the crops they planted, the meals they prepared. It is as though the soil itself has kept a record, not just of civilizations but of daily life, details too small, too ordinary to leave in stone or pottery, yet captured nonetheless in dust. The process of reading this memory is delicate, almost ritualistic. Scientists collect soil, break open its mineral shells, and gently coax out fragile strands of DNA. Because these molecules are few and frail, they are copied many times using a method called polymerase chain reaction until they can be read. Sequencing machines then translate the fragments into letters, comparing them to vast libraries of known species. It is like piecing together a manuscript that has been torn into shreds. Individual words may be missing, but with enough fragments, the story can be read. But this work carries danger too. DNA is everywhere, floating in the air, clinging to skin, drifting on every breath. It is easy to confuse the present with the past. So laboratories become like temples of silence and sterility, clean rooms where scientists work in gowns and masks, careful not to let a single stray molecule contaminate the archive. The irony is quiet but sharp. Soil can hold the memory of a mammoth for 10,000 years, but the careless sneeze of a researcher could erase it in an instant. The gift of soil DNA is not limited to ancient history. It is also a tool for the present. Conservationists use eDNA to track rare and vanishing species without ever needing to see them. A few strands in the ground may reveal the presence of a hidden frog, a shy predator, or an invasive plant. Through this molecular memory, soil becomes not only a historian but also a guardian. There is something profoundly poetic about this hidden archive. A mammoth, crossing a frozen plain, could not have imagined that its cells, scattered and buried in frost, would one day be read by human eyes. A flower dropping its petals into the dust could not have known that fragments of its DNA would one day testify to a climate warmer than today. Soil does not forget. It does not judge. It does not hurry. It simply waits, holding its memory patient for those who know how to read. The scale of this memory humbles us. Human recollection reaches back only a few generations. Written history extends only thousands of years. But soil DNA stretches back into epochs when ice sheets blanketed continents, when deserts were seas of green, when creatures now vanished were alive and ordinary. To hold a vial of ancient soil is to hold not dirt, but a census of a lost world. And yet, this archive is fragile. DNA breaks, unravels, decays. Whole chapters are erased before we can glimpse them. What remains is patchwork, partial, imperfect. And yet even these fragments are luminous, like scattered stars across a dark sky. Enough survives to remind us that what we see today is only a single instant in an unbroken story, a story the soil has been writing slowly, quietly, across millions of years. The return of life after catastrophe is never only the work of seeds and sunlight. Beneath the surface, armies of microbes had already prepared the stage, drawing on memories of disturbance and renewal. In their quiet, unseen way, they are the keepers of the soil's living history, ensuring that the story of life continues no matter how often it is interrupted. Nowhere is this cycle more vivid than in fire. Fire has always been both destroyer and creator, sculptor and storyteller. To watch flames sweep across a forest or grassland is to witness transformation compressed into hours. Trees collapse in showers of sparks. Animals scatter. The air turns thick and red. The land is undone in a rush of heat. And yet long after the smoke has cleared, long after the embers have cooled and the trunks have fallen silent, the memory of fire lingers in the soil. Charcoal and ash, blackened fragments of wood, mineral-rich dust, all remain as quiet testimony to the heat that once roared above. The soil does not forget. It carries these signatures for decades, centuries, sometimes even millennia. Charcoal, though fragile to the eye, is surprisingly durable. It forms when wood and leaves are heated in the absence of enough oxygen to burn completely. Instead of turning to ash and smoke, they carbonize, leaving behind lightweight fragments that resist decay. These bits of charcoal can slip into soil horizons, tucked away and preserved for thousands of years. Archaeologists and soil scientists often find them embedded in profiles, each black fleck a frozen spark from a fire that once burned. Because charcoal is stable, it becomes a permanent bookmark in the soil's diary, a dark page that refuses to fade. Ash tells a different story. Unlike charcoal, it is the residue of complete combustion, the final mineral skeleton left behind after everything organic has vanished. Calcium, potassium, magnesium, and other elements, stripped from living tissue, are concentrated in this pale dust. Ash is lighter, more vulnerable to wind and water, more likely to wander than stay. Yet when it settles, it transforms. It alters the soil's chemistry in sudden, dramatic ways. Some ashes make the soil more alkaline, tilting the balance of what plants can take root. Others provide a sudden flush of nutrients, fueling bursts of regrowth. To find an ash layer in a soil profile is to glimpse both destruction and renewal, a scar and a seed written in the same stroke. Scientists read these fire traces like pages of a chronicle. By measuring the density and distribution of charcoal, They can reconstruct how often fires visited a landscape. In some regions, layers show a steady pulse, evidence that wildfires swept through regularly, almost rhythmically, like seasons. Elsewhere, the silence of charcoal suggests long spans without fire. From these patterns, scientists learn not just the history of flame, but how ecosystems themselves were tuned to it. Grasslands, for example, often show frequent charcoal layers, reminders that their very existence depends on regular burning to prevent forests from swallowing them. Forest soils, by contrast, may reveal rare but violent infernos, reshaping everything in a single event. Volcanic eruptions leave even more dramatic marks. When a volcano explodes, it sends ash plumes into the sky, raining over vast distances, blanketing rivers, fields, and mountains. These ash layers, called tephra, are unmistakable. Each eruption carries its own unique mineral fingerprint. By matching the chemical makeup of ash horizons across continents, scientists can trace the spread of a single eruption and date it with astonishing precision. A thin grey band hidden in a soil profile is like a timestamp pinned to the Earth's calendar. Consider Mount Mazama's Great Eruption, about 7,600 years ago, which carved Oregon's Crater Lake. Its ash fell across much of North America, settling into soils thousands of kilometers away. Even today, when scientists dig in the right places, they encounter that pale layer instantly recognizable as Mazama's mark. It is a perfect example of soil as archive. Beneath a farm field, beneath a forest floor, lies a faint reminder of a day when the sky itself turned to fire. Wildfires, though smaller in scale, also leave chemical fingerprints that endure. The heat alters minerals, reshaping how clays hold water, unlocking nutrients bound in organic matter. After fire, soils often brim with phosphorus and potassium, an invisible inheritance that explains why new plants sprout so vigorously, why some species require fire to return at all. Even seeds remember flame. Certain pines and grasses will not germinate until fire has cracked their shells or smoke has washed over them. In this way, the soil holds not only the ashes of fire, but the very instructions for life's rebirth. Human fires, too, are etched into the ground. Long before cities and industries, people used flame to clear, to cook, to shape their world. Charcoal horizons mark the presence of ancient hearths and land clearings. In the Amazon, soils rich with charcoal mingle with dark earth known as terra preta, evidence of deliberate burning to nourish crops. These layers remind us that soil remembers culture as well as climate, that humanity has been inscribing itself into the ground with smoke for thousands of years. Charcoal does more than preserve memory. It acts like a sponge, holding water and nutrients that might otherwise slip away. It provides surfaces for microbes to colonize, forming little shelters where life can take root again. Soils enriched with charcoal often prove more fertile than before, paradoxical gifts of destruction. Fire consumes, but in its wake it leaves the possibility of abundance. Yet fire sep's legacy is not always generous. Repeated, intense burning can strip soil of its organic matter, robbing it of its capacity to hold water, making it brittle, prone to erosion. Sometimes the heat creates hydrophobic layers, particles coated in water, repelling compounds, so rain runs off the surface instead of soaking in. The land hardens. The memory of fire becomes an obstacle to renewal. The soil remembers not just that a fire happened, but how often it returned, how fiercely it burned, how deeply it seared the ground. It remembers whether the aftermath was fertile or barren, whether regrowth flourished or faltered, whether the forest rose back quickly or remained scarred for decades. Every layer of charcoal, every trace of ash, Every subtle chemical shift is another line in its long, unhurried story. The soil holds these fiery chapters alongside the voices of pollen, DNA, dust and stone, weaving them together into a great tapestry of memory that stretches across the ages. It remembers not only the presence of flame, but its severity, and this memory shapes the landscape for generations. From a broader perspective, charcoal and ash are more than relics, they are windows into climate history. By examining charcoal records across continents, researchers can trace the pulse of global fire. They see how flames rose and fell with shifts in climate, how humans altered fire regimes, how ecosystems learned to live with flame or to perish without it. The soil's blackened flecks and pale mineral bands become lines in a planetary chronicle, one that links earth, air and fire into a single narrative. It is humbling to realize that beneath a quiet meadow, beneath a suburban backyard or a forgotten pasture, there may lie the survivors of ancient infernos. A single charcoal fragment, light as a feather, dark as midnight, is a fossilized spark, a piece of flame captured and preserved. It is a reminder that the landscapes we see as stable have been burned, remade and burned again, over and over through centuries. The soil does not exaggerate these events, nor does it dramatize them. It simply holds the record, waiting for someone to notice. There is a strange poetry in this resilience. Fire itself seems fleeting. A blaze roars for a night, a season, and then vanishes, leaving only smoke dissolving into the sky. And yet its traces endure, quiet and unassuming, written into the ground. Charcoal and ash linger, woven into the soil's very fabric. Fire consumes, but it cannot erase itself. The earth remembers patiently, in layers that persist long after the flames have gone. The next time you walk across a scorched hillside, or stand at the rim of a dormant volcano, remember this: beneath your feet lies a story already written. The soil beneath carries the memory of fire, not in words, not in photographs, but in particles and chemistry. Every charcoal fleck is a fossilized spark. Every pale smear of ash is a captured plume of smoke. Together, they tell a tale of destruction and renewal, of landscapes remade, of the earth's unbroken ability to remember. Wherever humans have lived, the soil has taken note. Long before we raised monuments or carved symbols into stone, the ground itself was already recording us. Our agriculture, our cities, our fires, our waste, every act left a mark. Soil may seem mute, but it remembers the rise of villages, the spread of fields, the bustle of marketplaces, the quiet rhythms of everyday life. To an archaeologist or soil scientist, dirt is not simply background material. It is an archive of human presence layered quietly beneath our feet. One of the most profound shifts we ever imposed on soil was agriculture. When early farmers broke the earth with stone blades and wooden plows, they disrupted its natural layering. They mixed organic matter with minerals, exposed deeper sediments to air and rain. They planted new species, leaving behind distinctive pollen grains and seeds. They burned fields to clear them, adding charcoal to the mix. Over time, these acts etched deep signatures into the ground. Even now, ancient fields reveal themselves as faint ridges, the shadows of old plough marks. Even when forests have reclaimed the land, the chemical traces of cultivation remain: phosphorus from fertilizers, residues from crops, altered microbial communities adapted to disturbance. Phosphorus is especially telling. It is essential for plant growth, and wherever humans have gathered, cooked, or discarded waste. Thousands of years later, scientists can still map the outlines of vanished villages simply by testing the soil. The richest concentrations align with hearths, corrals, middens, and waste pits, the places where life was most intense. In this way, the ground becomes a silent census, a map of communities long gone. Cities leave even more dramatic marks. In ancient urban centres, layers of compacted earth, ash, brick fragments, pottery shards, animal bones, and organic waste accumulate into thick deposits known as middens. They are not just piles of debris, they are stratified archives of daily life. Seeds of crops, residues of dye and metalwork, fragments of food and drink, all preserved in soil. A city may crumble into ruins above, but beneath the surface its story continues, written in chemistry and clay. Consider Roman Britain. Archaeologists studying soils in former Roman towns find elevated lead levels, a legacy of plumbing, coins, and glazed pottery. Even where the buildings have vanished, the ground still carries the chemical echoes of Roman life. Elsewhere, medieval tanneries left behind soils rich in lime and organic matter. Ancient metallurgists seeded the earth with copper, arsenic, and mercury. Farmers burning stubble wrote layers of charcoal into the soil's record. Every activity inscribed its own chemical entry in the earth's diary. Waste, too, leaves its mark. For millennia, people tossed scraps of food, ash, broken tools and bones into pits, or simply onto the ground. Over centuries, these deposits transformed into rich, dark soils. In the Amazon, such soils are called terra preta, black earth. They are fertile patches created by people thousands of years ago, filled with charcoal, bone, pottery, and organic matter. Unlike the poor native soils around them, they remain productive even today, living proof that human footprints can persist not just as ruins, but as enriched landscapes. Even the least glamorous traces, labyrinths, rubbish pits, forgotten hearths, speak in their own way. They enrich the soil with nitrogen, phosphorus, and carbon, leaving hotspots that can still be detected centuries later. Sometimes even the microscopic remains of parasites survive, revealing which diseases afflicted past communities. It is a reminder that soil remembers not only the monuments and the mighty, but also the most ordinary, intimate details of daily life. The earth does not discriminate. It stores the record of meals as faithfully as it does the record of wars. And war, too, is etched into the ground. Old battlefields contain elevated levels of lead from musket balls, bullets, and shrapnel. Rusting iron from weapons and armor leaches slowly into the soil. Scorched layers mark the destruction of villages and fortifications. Sometimes, mass graves leave behind chemical shadows, detectable even when bones have long since crumbled. Soil remembers these darker chapters without sentiment, holding on to memories of violence long after the smoke has drifted away. What is striking about all these footprints is their persistence. Soil forms slowly, and once something enters it, that trace can endure for centuries or millennia. Even seemingly minor activities accumulate into lasting signatures. A few seasons of farming can leave changes visible thousands of years later. A single volcanic eruption can preserve the outlines of human presence in astonishing detail. In this way, soil often proves more reliable than human memory itself, holding on long after our recollections fade. Modern science is learning how to read these hidden pages with ever greater precision. Soil micromorphology allows researchers to slice soil into thin sections, place them under microscopes, and examine its layers like a geologist might study rock. Tiny flecks of charcoal, invisible grains of ash, faint traces of organic matter, all become legible. Other methods study isotopes, distinguishing human waste from animal waste, separating the remains of barley from wheat, or tracing the sources of fertilizer. Through these tools, archaeologists can reconstruct ancient diets, farming practices, even settlement patterns in remarkable detail. Soil is no longer just background material. It is a witness, a storyteller, a participant in the unfolding of history. Yet soil memory is not always gentle. It also holds the record of our industrial age. Pollution from factories, pesticides from fields, plastics from every corner of modern life, all of it is now being folded into soils worldwide. Just as today's scientists can read the traces of Roman plumbing or Maya agriculture, the scientists of tomorrow will read our legacy of fertilizers, synthetic chemicals, and microplastics. This is what geologists mean when they speak of the Anthropocene, a new epoch shaped by human activity. Our story is already written not just in rocks and glaciers, but in the very dirt beneath our feet. Still, amid all these inscriptions there is resilience. Soils do not merely absorb and preserve, they recycle, adapt, and transform. Microbes break down organic matter. Earthworms churn horizons, mixing the layers. Plants draw nutrients upward, weaving decay back into life. The soil sip's memory is dynamic, not frozen. And that makes it even more remarkable that so many signatures survive at all. Phosphorus, charcoal, heavy metals, these persist for centuries even as everything else is in flux. They are stubborn echoes of our presence, etched deeper than we might imagine. It is humbling to realize that even a single footprint is more than a temporary impression. Beneath that step may lie centuries of human influence, a palimpsest of countless lives. Soil records our stories without bias, our triumphs and our mistakes alike. It remembers the first furrows carved by agriculture, the bustle of ancient cities, the scars of battle, and the quiet rhythms of cooking fires. It is perhaps the most democratic archive we have, preserving the lives of common people alongside those of kings and empires. In the heart of the Amazon rainforest lies one of the soil's greatest puzzles, a mystery that has fascinated scientists, archaeologists, and farmers alike. Amid landscapes where the earth is famously poor, thin, exhausted, quickly leached by heavy rain, there are scattered patches that defy expectation. These soils are dark, rich, and astonishingly fertile. They support crops year after year without losing vigor. They are known as terra preta, or dark earth, and they form a patchwork across the Amazon basin, human dot-made islands of fertility in an otherwise unyielding environment. Their existence poses a remarkable question. How did ancient people transform some of the most nutrient-poor soils on Earth into ones that remain productive even now, centuries after their makers have vanished? The natural soils of the Amazon, called oxysols, are typically red or yellow, deeply weathered and stripped of nutrients. Heavy rains wash minerals downwards, leaving little to sustain crops. Farmers who try to cultivate these soils without fertilizers often watch their harvests collapse after just a few years. For a long time, scholars believed that no large dot-scale societies could have flourished here, that the rainforest was too harsh, too poor, to sustain complex civilizations. But the discovery of terra preta tells a different story. Here, ancient communities enriched the soil with charcoal, bone fragments, food waste, and organic matter. Through repeated cycles of burning and composting, they created earth that is darker, more stable, and more fertile than anything nature alone had produced. These soils resist leaching, hold water and nutrients, and remain productive for centuries. Even today, farmers prize them. Terra preta is more than a curiosity of soil chemistry. It is proof that human memory can be written into the land not only as scars but as gifts. It shows that people of the past knew how to transform fragility into resilience, how to shape ecosystems in ways that endure. Just as charcoal preserves the memory of fire, these black earths preserve the memory of ingenuity, care, and human presence woven into the very ground. People found a way to engineer soil that could sustain them indefinitely. Terra preta is striking to see. Its blackness is deep and unmistakable, a dark hue born from an abundance of charcoal. The contrast is dramatic. Black earth against the surrounding red and yellow oxysols, like ink poured onto faded parchment. Farmers who know these soils recognize them instantly. They still prize them, working them as their ancestors did, grateful for their fertility. Unlike the thin and fragile soils around them, terra preta can yield maize, cassava, beans and fruits year after year, resisting exhaustion. This endurance is not natural. It is crafted. It is the patient result of countless human hands tending fires, discarding scraps, and slowly transforming the earth itself. At the heart of terra preta is charcoal, often called biochar in this context. Ancient Amazonians appear to have made it deliberately, using controlled, low-dot oxygen fires to smolder wood and plant matter rather than burn it to ash. This left behind carbon-rich fragments that resist decomposition for millennia. When mixed into soil, charcoal does something extraordinary. It becomes a sponge. Its pores and surfaces capture nutrients, cradle water and shelter microbial life. Charcoal keeps fertility from leaching away. It makes the soil not only richer, but more resilient. Yet charcoal alone was not the secret. Into this matrix people added food scraps, plant clippings, fish bones, animal waste, and even their own refuse. They layered fertility into the earth, cycling waste into nourishment. Together with charcoal, these additions created a soil that did not merely store nutrients, it regenerated them. It was, in effect, composting written into the land, a slow alchemy that turned fragility into abundance. The microbial world of terra preta is equally remarkable. These soils teem with life, harboring microbial communities far more diverse and abundant than their surroundings. Charcoal offers habitat, tiny caves and crevices where microbes can thrive. The microbes, in turn, break down organic matter, recycle nutrients and sustain the fertility of the soil. This living partnership has lasted for centuries. Even now, thousands of years after their creation, many patches of terra preta remain fertile, feeding crops as though the ancient farmers had only just left. What is astonishing is not simply the productivity of terra preta, but its persistence. Soils normally lose fertility quickly in the tropics, exhausted by rains and heat. Yet terra preta endures. Some patches are over 2,000 years old, still vigorous, still sustaining harvests. It is as if those early farmers discovered a recipe for soil immortality. They wrote their knowledge into the ground, and the ground remembers. The scale of these black earths also rewrites our view of the Amazon's past. For much of the 20th century, scholars imagined the rainforest as sparsely inhabited before European arrival, home only to scattered bands of people living lightly on the land. But the widespread presence of terra preta suggests otherwise. Its creation required planning, cooperation, and continuity across generations. It hints at large, organized communities who systematically enriched their soils, managing landscapes on a vast scale. Some estimates suggest that up to 10% of the Amazon basin may bear the marks of terra preta. If so, then far from being untouched wilderness, the Amazon was once a human dot-shaped garden, tended by people who understood its rhythms. The story of terra preta also reaches into the present. Scientists and environmentalists now study biochar as a tool for sustainable farming and climate resilience. By adding charcoal to soils, modern farmers can reduce fertilizer use, retain nutrients, and even lock carbon underground for centuries, helping slow climate change. In this way, the wisdom of ancient Amazonians whispers to us still, offering solutions to challenges they could never have imagined, yet which we now urgently face. There is poetry in this endurance. While stone monuments crumble and wooden temples decay, these soils remain. The people who created them may not have raised pyramids or palaces, but they left something more profound, a living legacy. Every handful of dark earth carries the fingerprints of cooks tending hearths, farmers spreading waste, families discarding scraps. Ordinary acts, repeated for generations, built a soil that has outlived them all. It is a reminder that memory need not be carved in stone to last. Sometimes it can be cultivated in the ground, written in carbon and nutrients instead of words. Terra Preta invites us to rethink our relationship with soil. These ancient communities did not simply deplete the earth, they enhanced it. They prove that humans are not only capable of destruction, but also of creation, of leaving behind landscapes more fertile, more generous than the ones they inherited. It is a lesson in humility, but also in hope. The soil remembers us, and with care, it can remember us kindly. In the end, Terra Preta is more than fertile ground. It is proof that humanity has always been an engineer of the earth, not only to survive, but to flourish. It stands as one of the most enduring testaments of human creativity, hidden not in towering monuments but in the quiet richness of soil. Thousands of years later, the Amazon's black earth continues to feed life, carrying forward the memory of its makers, one grain at a time. And this is where the story circles back to something deeper. For as long as humans have told stories, soil has been more than matter. It has been symbol, stage and scripture. We plant our seeds in it. We bury our dead in it. We draw metaphors of creation and return from it. Science shows us how soil holds the physical memories of fire, pollen, DNA, and stone. Culture shows us how it has always held our imagination as well. In myths and rituals across the world, the earth beneath our feet has been revered, feared, celebrated, seen not merely as ground to walk on, but as the very origin of life. Soil has always been more than matter. It has been the medium of creation, the body of the gods, the breath of fertility, the cradle to which all things return. In ancient Greece, Prometheus was said to have fashioned the first people from clay, shaping their bodies from moist earth, and then kindling within them the spark of fire. The goddess Gaia herself was the ground embodied, the fertile mother whose body gave rise to mountains, rivers, and the endless procession of life. Across the world in China, myths tell of the goddess Nua moulding humans from yellow clay, her fingers pressing form into formlessness, giving shape and spirit in a single act. Soil in these stories is not dust or debris, it is the very fabric from which living beings are woven. The idea that we come from earth and return to it is a theme so widespread it may be universal. Burial practices echo this belief across cultures. To bury the dead in the ground is to return them to the substance from which they came, a gesture of closure, but also of continuity. In ancient Egypt, the fertile black silt of the Nile was linked to rebirth, and so burials became acts of hope, seeds planted in the soil of eternity. In many indigenous traditions of North America, earth is spoken of as a motherly figure, a patient presence who receives the dead with care, making soil at once a grave and a womb. Even today, the act of burial carries symbolic weight, affirming the cycle of life, death, and regeneration that soil represents so perfectly. Soil has also long been bound to fertility rituals. In farming communities, handfuls of sacred earth were scattered across fields to ensure good harvests. In India, the festival of Holi includes rituals with earth and ash, celebrations of renewal, fertility, and the eternal return of growth. In parts of Africa, ceremonies involve smearing soil on the body as blessing, a way of binding human life to the fertile ground that sustains it. The logic is simple but profound. The same soil that grows crops also nourishes human life, and by ritually joining with it, people hope to share in its abundance. There are traditions in which soil serves as witness. In medieval Europe, oaths were sworn with a clot of earth held in the hand, a reminder of one's bond to the land and the weight of the promise made. In Japan, Soil from battlefields was gathered to honor the fallen, binding memory to the earth itself. Even today, migrants sometimes carry soil from their homelands in pouches or jars, a way of keeping memory alive. To hold soil from home is to hold a piece of identity, a tangible reminder of roots, both literal and symbolic. Agriculture reveals the sacred dimension of soil most clearly. The first farmers did not see soil as inert substrate for plants. They saw it as alive, a presence deserving respect. Calendars of planting and harvest were often tied to rituals of blessing the earth, offerings given before taking. Roman religion honored Tellus, the goddess of fertile ground. In the Andes, Pachamama, the Earth Mother, was fed with libations of food and drink poured directly into the soil. These practices reveal an ancient intuition: to take from the earth is also to give back, for the ground remembers both generosity and neglect. Even today, echoes of this cultural memory shape our language. Expressions like down ... earth, grounded, or the salt of the earth, all reflect the association of soil with honesty, humility, and reliability. To be rooted is to belong. To be uprooted is to lose place. Soil shapes not only our crops but also our metaphors, embedding itself in our thought as deeply as in our fields. Yet the cultural memory of soil carries shadows as well. In lands scarred by war, soil itself is seen as stained. Survivors have described battlefields as haunted ground, remembering blood spilled into it. Folklore tells of restless spirits lingering in disturbed earth, reminding us that soil is linked not only with fertility and renewal, but also with suffering and death. Archaeological sites show how soil was used with deliberate symbolism. Indigenous mound builders of North America carried soils from distant places, chosen for their color, their fertility, or their sacred associations, and layered them into ceremonial earthworks. In parts of Europe, chalk or clay was transported to ritual sites, as though the soil itself were a participant in the ceremony. Such choices reveal that earth was not background, but an active presence, a material imbued with meaning. What is striking across all these examples is how soil remains central to human life and imagination in every time and place. Whether it is the black silt of the Nile, the red clay of Africa, the yellow earth of China, or the dark loam of Europe, soil has always been more than a foundation. It is a repository of stories, a medium of ritual, a symbol of permanence and transformation alike. Even science, with its precise instruments, sometimes mirrors these ancient intuitions. To say soil has memory is to echo the metaphors of myth. The earth remembers. Scientists may mean this in terms of chemical records, isotopes, and microbial signatures, yet the resonance is unmistakable. Humans have always sensed that the ground beneath us keeps faith with the past, whether in the fertility of crops or in the presence of ancestors. To walk across a field or through a forest is not merely to step on natural ground. It is to pass over centuries of stories, beliefs, and lives. Soil is both archive and altar, both record and symbol. In the end, the cultural memory of soil reminds us that the earth has never been just dirt. It has been a teacher, a companion, a witness, a sacred presence. It has carried myths of creation, received the weight of burials, blessed harvests, and grounded our language. Soil is alive not only with organisms and molecules, but with meaning, and meaning runs deep. When the last ice age began to loosen its grip, glaciers that had ground across continents began their slow retreat. For thousands of years, ice had dominated the land, scouring valleys, crushing mountainsides, leaving little more than raw stone in its wake. But when the climate warmed and the ice melted back, it revealed landscapes stripped bare, scraped clean, and seemingly lifeless. From that blank canvas, soils began to form. Slowly, patiently, they gathered from dust, from lichen, from the decay of the first plants that dared to root in the new light. Today, the soils left behind by glaciers still carry the story of transformation. They hold the memory of ice, of barren stone becoming living ground. Just as surely as myths remember creation and cultures remember ancestors, the soil remembers the age of glaciers, and as always, it remembers quietly beneath our feet. Glaciers are sculptors of the earth. As they advance, they pluck boulders from mountainsides, grind valleys into shape, and crush rocks into a fine powder known as glacial flour. When they retreat, they leave these materials scattered in their wake, spread thin across plains or heaped into ridges called moraines. At first, this debris is lifeless. It is raw stone, unsorted gravel, fine dust. No humus, no roots, no microbes, just the residue of ice. But the story does not end with retreat. Over time, weather and biology begin their slow work. Rain seeps into cracks. Frost shatters boulders. Wind carries seeds across the empty ground. The earliest pioneers arrive, lichens that cling to bare rock and secrete acids to dissolve minerals, freeing hidden nutrients. Mosses follow, holding water in their spongy tissues, creating tiny damp sanctuaries for bacteria, fungi, and the smallest invertebrates. When these first colonizers die, their remains mix with the mineral dust, forming a fragile proto-dot soil. It is thin, delicate, easily washed away, but it is a beginning. From these meager foundations, soil slowly thickens. Microbes multiply, breaking down organic remains, cycling nutrients, enriching the ground. Over centuries, this invisible labor prepares the way for grasses, then shrubs, then trees. What begins as a barren field of stone becomes meadow, then forest. Much of the greenery that now cloaks the northern hemisphere owes its existence to this patient process. Without soils born from glacial debris, the forests, wetlands, and farmlands of today would have had no foothold. The soils of glacial landscapes are distinctive. They bear the fingerprints of ice. Their textures are mixed. Gravel, sand, silt, and clay jumbled together in chaotic deposits. Horizons are shallow, for these are young soils by geological standards. Yet within their profiles lie unmistakable traces of the frozen past. Till, the unsorted rubble dropped directly by melting ice, lies heavy and dense. Varves, the delicate annual layers of silt and clay left behind in glacial lakes, record meltwater pulses with calendar dot-like precision. Each band is a line in the diary of a changing climate, preserved for those who know how to read it. Post-glacial soils have played a quiet but profound role in regulating Earth's climate. As plants colonized the freshly exposed ground, they drew carbon from the air, locking it into organic matter stored in the soil. This long, steady sequestration helped stabilize the atmosphere during the Holocene, the epoch in which human civilization would later arise. Even now, soils in once-glaciated regions hold vast reserves of carbon, a living memory of recovery after ice. In the far north, permafrost tells another story. Frozen soils preserve the organic remains of ancient ecosystems, grasses, roots, even animal fragments, locked in cold storage for tens of thousands of years. As long as the ground remains frozen, this memory is secure, an unbroken record of a vanished world. But as permafrost thaws under modern warming, it releases carbon and methane back into the air, reawakening a long-silent influence. In this way, the legacy of Ice Age soils continues to shape our climate, even today. Soils also remember the return of life through pollen and seeds. As glaciers retreated and forests spread northward, pollen grains fell into forming soils, recording the succession of species. First came birches and willows, hardy pioneers of poor, stony ground. Later came oaks, pines, and others that built denser, richer forests. Soil cores from former glacial landscapes reveal these transitions with exquisite clarity. Each layer of pollen is a page in the record of resilience, a chronicle of how landscapes healed. Human history, too, is deeply tied to these soils. The fertile plains of northern Europe, built on glacial deposits, became early centers of agriculture. The American Midwest, enriched by thick layers of glacial loess, grew into one of the most productive farming regions in the world. Even the deep black soils of Ukraine trace part of their richness to glacial legacies. Where ice once stripped the land, it also laid the foundation for abundance. Soil, in remembering ice, became the bedrock of civilization. There is a striking beauty in this paradox. The same ice that stripped landscapes bare also prepared the ground for renewal. The soils that formed in its wake carry both scars and gifts, records of grinding destruction and the nutrients of rebirth. To study a glacial soil is to see devastation and recovery pressed into the same profile, destruction giving way to resilience. The lesson of post-glacial soils is one of patience. Ecosystems do not spring back overnight. It can take centuries for soils to deepen enough to support complexity, millennia to reach the richness we now take for granted. Yet given time, even the harshest landscapes can be transformed. The forests we walk through, the fields we cultivate, the meadows alive with flowers, all stand on ground that was once scraped raw by ice. The fact that these places now hum with life is a quiet miracle written into the soil. The earth remembers the ice not with bitterness, but with balance. It remembers the grinding weight, the barren aftermath, and the long return of life. Beneath our feet that memory endures, patient, unhurried, and alive. This is more than a memory of climate. It is a quiet reminder of nature's ability to rebuild grain by grain, layer by layer. In the end, the soils left behind by glaciers are not merely geological leftovers. They are chronicles of change, recording cold ages and warm recoveries, devastation followed by renewal. To walk across them is to walk across pages of Earth's diary, where the story of ice and rebirth is written in every particle. And soil does not only remember in the vast timescales of geology, it also remembers in ways far more immediate, ways that touch human history and human justice. Soil may not look like much of a witness. It does not raise its hand, it does not speak aloud, and it does not point a finger in a courtroom. Yet in its own quiet way, soil is one of the most reliable record keepers we have. Every patch of ground is unique. Its chemistry, its mineral composition, its structure, and its living inhabitants give it a character as individual as a fingerprint. This uniqueness makes soil more than backdrop. It makes it evidence. Dirt clings stubbornly to shoes, tires, tools, and clothing. Forensic scientists have learned to read these traces, turning the ground beneath our feet into testimony. The idea of soil as evidence is not new. As far back as the 19th century, forensic pioneers noticed that mud carried on boots could tie a suspect to a particular location. In 1904, the Austrian criminalist Hans Gross described soil as one of the most overlooked yet invaluable forms of trace evidence. A generation later, the famous investigator Edmund Locard, whose principle that every contact leaves a trace became a cornerstone of forensic science, emphasized that soil, no less than blood or fingerprints, could connect people to places. While other forms of evidence often steal the spotlight, soil has quietly solved mysteries for more than a century. One reason for its power is variety. Even within a few steps, soil can change in texture, color, and mineral makeup. One patch may be sandy, another clay, rich, another flecked with microscopic quartz or volcanic glass. Some soils bear chemical fingerprints of fertilizers or industrial residues. Others carry minerals tied to the unique geology of a region. Under a microscope, soil reveals distinctive grains, crystal structures, and even fragments of organic matter. Add pollen grains, fungal spores, insect parts, or traces of DNA, and each soil sample becomes a complex, unmistakable signature of place. This precision has been decisive in famous cases. In 1959, soil traces on the tyres of a car linked British serial killer John Bodkin Adams to a burial site, sealing his conviction. In recent years, advances in geochemistry have sharpened this detective work. Isotope ratios in soil can reveal the climate in which it formed. Magnetic particles shaped by local rocks or human industry can serve as markers as unique as fingerprints. What once seemed like anonymous dirt is now recognized as a highly specific record of location. Archaeology, too, has long relied on this silent witness. Excavated soils do more than cradle artifacts. They tell the story of how people lived. High phosphorus levels often mark the presence of ancient hearths or midden heaps. Microscopic charcoal signals long ago fires. Layers of compacted earth reveal pathways and floors where generations once walked. Soil chemistry can even preserve hints of diet, what crops were cultivated, which animals were kept nearby. Through such readings, archaeologists reconstruct daily life in villages that crumbled thousands of years ago, even when no walls or roofs remain. Forensic soil science also extends to the darkest chapters of history. In investigations of war crimes, disturbed soils have helped locate mass graves. The ground remembers where it has been dug, filled, and pressed down. Changes in compaction, unusual residues, or shifts in microbial communities mark sites of hidden tragedy. Once uncovered, the soil itself may yield DNA fragments, linking remains to lost individuals. In this way, Earth serves both as witness and as evidence, helping families find closure and giving history accountability. Tracking movement is another powerful gift of soil. Dirt clings invisibly, yet persistently, to shoes and clothing. A smear of dust can betray where a person has walked. Pollen lodged in soil can reveal whether the path ran through a meadow, a forest, or a field of crops. Microbial signatures can point to a farm, a wetland, or an urban park. In legal cases, comparing soil from a suspect's belongings with soil from a crime scene can weave a chain of connection stronger than testimony. In border security and anti-smuggling operations, soil analysis has even traced shipments back to their places of origin, turning dirt into a map of movement. And this detective work is not limited to human crime. Ecologists use soil in a similar way, tracking the spread of invasive species. DNA fragments in soil reveal whether plants or animals have passed through. By studying soil samples, scientists can detect the footprints of intruders long before they are visible on the landscape. Soil, in this sense, is not only a record of what has happened, but a tool for predicting what may come. Everywhere we look, soil proves itself both archive and accomplice, keeper of memory and revealer of secrets. It remembers glaciers and civilizations, footsteps and crimes, crops and fires. To learn how to read soil is to learn how to read time itself, not as a smooth line but as a layered record where human lives and natural forces meet. Its memory reaches even into the movements of animals and the migrations of plants. Soil can reveal the path of livestock across ancient landscapes, the origin of crops carried from one valley to another, and even the spread of diseases that once swept through communities. In this sense, soil's memory functions almost like a silent surveillance system, recording comings and goings that would otherwise vanish without trace. What makes forensic soil analysis especially fascinating is how it brings together so many sciences. A single pinch of earth can demand the skills of a geologist, a chemist, a biologist, even a climate scientist. Under the microscope, mineral crystals flash with color when examined in polarized light. Chemical tests reveal trace elements in parts per million. DNA sequencing uncovers fragments of organisms both living and long dead. Each line of evidence is like a thread, and when woven together, they form a profile so distinctive that a handful of dirt can be tied with remarkable certainty to a single patch of ground. Despite this power, soil evidence has not always been taken seriously. In courtrooms, dramatic forms of evidence, bloodstains, fingerprints, strands of hair, have often stolen the spotlight. Soil, humble and overlooked, seemed too ordinary to matter. Yet as methods have grown more precise and more standardized, soil has proven itself again and again. Today, in some countries, soil scientists work side by side with law enforcement, collecting samples, comparing profiles, and building cases. What once seemed like dirt on a shoe is now recognized as evidence that can carry enormous weight in the pursuit of justice. There is also a kind of quiet philosophy to this. When a person walks across a meadow or down a city street, they do more than leave footprints. They take part of that place with them, tiny particles of soil that cling to their shoes or clothing. Soil embodies the principle that no action is without record. Every movement leaves a trace. Every contact leaves a signature. The earth remembers even when people try to forget. Beyond its practical applications, forensic soil science highlights the sheer richness of the ground beneath us. What appears to be dust can turn out to be a layered library, minerals born of ancient mountains, pollen from local plants, spores from fungi hidden in the shade, even microscopic echoes of human activity from centuries past. Each speck is a story compressed into grain, ready to reveal its secrets to those who know how to listen. Soil as detective's memory is a reminder that the earth is never inert. It listens, it absorbs, it preserves. It does not judge, but it does not forget. Whether uncovering the daily routines of ancient villages, solving modern crimes, or tracing the spread of life across continents, soil testifies quietly and faithfully to where we have been and what we have done. It is the silent witness beneath our feet, always ready to speak when asked the right questions. To glance at the ground is to see only the present: grass, growing, roots threading through, insects burrowing. But to look deeper is to see that soil is layered not only in space but also in time. Each horizon is a page, and together they form a diary that stretches back thousands of years. With the right tools, soil becomes a time machine, carrying us into the past and revealing ancient climates, vanished ecosystems, even moments of human history long forgotten. The key to unlocking this time machine is the soil core. Using long, hollow tubes, scientists extract columns of earth, each one an intact cylinder that preserves layers in order. At the surface, you find the signatures of modern life, pollen from today's plants, residues of industrial pollution, the chemical imprint of agriculture. A little deeper, the story shifts. A grey band may mark volcanic ash from a distant eruption. A streak of charcoal may record a wildfire extinguished centuries ago. Deeper still, you find soils that formed under forests now gone, or grasslands buried by changing climates. Their chemistry still holds the memory of landscapes that vanished thousands of years ago. The beauty of soil cores is continuity. Unlike an isolated artifact or a single fossil, they preserve sequences, layer after layer, event after event, allowing scientists to trace not just what happened, but how things changed. By studying patterns in pollen grains, dust, carbon, and isotopes, they can see ecosystems evolving year after year, century after century. It is like holding a film reel of the past, though the images are written in grains and molecules rather than light. Radiocarbon dating sharpens this picture into time. All living things absorb carbon from the atmosphere, including a rare isotope called carbon-14. When they die, they stop taking it in, and the carbon-14 decays at a predictable pace. By measuring how much remains in a fragment of charcoal, a bone, or a seed preserved in soil, scientists can calculate when it was deposited. A layer of soil may tell you that a fire burned here. Radiocarbon dating can tell you it happened 5,000 years ago. Other isotopes add their own voices to the soil's diary. Beryllium-1, 0, born high in the atmosphere. When cosmic rays strike oxygen and nitrogen, drifts down through the air and settles into soils and sediments. Its concentration rises and falls with shifts in solar activity and wind circulation, giving scientists a record of forces that shape the planet from beyond the sky. Lead isotopes tell a more human story, tracing the first moments of mining, smelting, and metalworking, when people began to draw hidden ores from the earth and transform them into tools and weapons. Nitrogen isotopes record the arrival of agriculture, showing how early farmers enriched their fields with manure or fertilizers. Each isotope is like a separate dial on the soil's instrument panel, registering the rhythms of nature and the fingerprints of humanity side by side. This makes soil more than a diary. It becomes a kind of time machine, offering a perspective on the past that is both precise and continuous. One of the most vivid examples of this time-traveling ability comes from varves, the delicate annual layers of silt and clay that settle in glacial lakes. Each pair of dark and light bands marks a single year, as precise as the growth rings in a tree. By counting varves and studying their composition, scientists can reconstruct year-by-year records of climate and environment, stretching back tens of thousands of years. Soil, in this sense, is not only a diary, it is a calendar. Core samples from peat bogs are another treasure trove. Peat forms slowly as plants grow, die, and decay in waterlogged conditions where oxygen is scarce. Because decomposition is incomplete, layers of organic matter accumulate and build over centuries, trapping pollen, seeds, insects, and even the occasional tool or garment lost by humans. In some bogs, the record stretches back more than 10,000 years. These cores tell stories of forests advancing and retreating, of farming appearing and spreading, of fires sweeping through landscapes, and of rainfall patterns shifting over generations. Sometimes they preserve human remains as well, bog bodies naturally mummified in the acidic waters, their last meals still in their stomachs, their hair and skin preserved for millennia. In these haunting cases, soil is not only a time machine, but also a guardian of history. Sediment cores from lakes and floodplains offer equally detailed journeys into the past. Their layers speak of droughts recorded in cracked, parched mud, floods remembered in coarse sand deposits, agricultural expansion revealed in sudden surges of crop pollen. In some cores, the introduction of exotic species can be traced as their pollen appears for the first time, a quiet signal of human travel, migration, and global trade. Soil here becomes an archive of both natural change and human influence, its time machine carrying us through intertwined stories of culture and environment. Of course, soil does not preserve everything equally. Records can fade, especially in disturbed or dynamic soils. Microbes break down organic matter, burrowing animals churn layers together, water washes horizons away, and erosion removes whole chapters of history. Yet even these losses speak. A missing layer may testify to a flood, a landslide, or human disturbance. Absence itself becomes a kind of evidence. And the time machine does not only reach into the distant past. Soil records our own modern age with clarity that can be unsettling. Cores taken near industrial sites show sudden spikes of lead during the age of gasoline, radioactive isotopes marking mid-20th century nuclear testing, and fragments of plastics embedded in the newest layers. Future scientists will read these signals as easily as we now read volcanic ash or ancient pollen, recognizing them as markers of our time. Soil's time machine has no preference for heroes or villains. It records it all, patiently and without judgment. There is a quiet wonder in realizing that the ground beneath our feet is a timeline waiting to be read. The top few inches speak of the present, roots weaving, insects burrowing, leaves decomposing, but each step downward carries you deeper into history. To hold a soil core is to hold centuries of rain, fire, growth and decay, compressed into a slender column. Every band of color, every fleck of charcoal, every shift in texture is a moment preserved, a memory waiting to be interpreted. It may not resemble the time machines of science fiction, but in its quiet reliability, soil offers something more extraordinary, a real passage into the past, powered not by gears or flashing lights, but by patience and careful study. With a core, a microscope and a radiocarbon lab, we can travel back to the days of mammoths, the dawn of agriculture, or the first rise of cities. This journey is not only about looking backward, by seeing how climates shifted, how ecosystems adapted, and how humans reshaped the land, we gain clues about what the future may hold. The past and future are connected, and soil is the bridge between them. To read the earth beneath us is to journey through time, a journey that reveals not only what has been, but also what may yet be written in the layers still forming today. Water has shaped soil more than any other force. Every drop of rain, every river that floods its banks, every season of drought leaves an imprint that lingers long after the weather has passed. Soil remembers these wet and dry rhythms, storing them in its layers, its chemistry, and its very structure. To study soil is to read the memory of water, a record that explains not only landscapes but also the rise and fall of civilizations. Floods are among the most dramatic events written into the ground. When rivers spill over their banks, they spread silts and clays across the floodplains, layering the land with fertile gifts. Over centuries, these deposits accumulate, transforming barren ground into rich soil capable of sustaining human life. The Nile River's annual flood was the most faithful of these cycles, a predictable rise and fall that left behind a dark, nourishing silt so treasured that the ancient Egyptians called their homeland Kemet, the Black Land. Each year, the river wrote its memory into the soil, season upon season, building the foundation of one of humanity's most enduring civilizations. Even today, buried soils in the Nile Valley preserve the signatures of ancient floods, silent confirmations of the river's timeless rhythm. The Tigris and Euphrates rivers in Mesopotamia tell a similar yet more complicated story. Their floods also spread life, giving sediments, feeding the first great cities and empires. But unlike the dependable Nile, their waters rose with unpredictability. At times they deposited fine, fertile silts. At others they unleashed violent torrents, leaving behind thick bands of coarse sand. Archaeologists excavating ancient settlements have uncovered abrupt soil layers that reveal catastrophic floods, moments that may well have inspired the great flood myths passed down through generations. Here soils preserve a paradox. The same floods that nourished fields could also sweep entire communities away. Soils do not only remember abundance, they also record drought, often in subtle but unmistakable ways. When water grows scarce, evaporation leaves behind salts that crust across the surface. Hardened horizons of calcium carbonate testify to prolonged dryness, forming quiet but durable scars in the earth. In some profiles, alternating bands of fertility and desiccation stretch like entries in a diary, marking centuries of shifting rainfall. Few stories illustrate this more clearly than that of the Maya in Central America. For centuries, Maya farmers cultivated maize, beans and squash in fertile lowland soils, building thriving cities among the forests. Yet soil studies reveal that during the 9th century, prolonged drought left unmistakable traces, hardened layers, chemical residues and pollen records, showing declining forests as desperate people cleared more land in search of food. Eventually, many great cities were abandoned. The soils remember those dry years as faithfully as they remember the flourishing that came before, offering insight into how climate change and water scarcity shaped the destiny of a great civilization. In China's Laos Plateau, thick deposits of wind-blown dust have been reworked again and again by water. The soils here hold alternating layers that tell of wet and dry cycles, some horizons well developed and rich, evidence of stable, moist conditions when vegetation flourished, others little more than loose, unformed dust, signs of parched, windy eras. These layers are more than natural history. They align with the waxing and waning of dynasties, linking human fortunes to the monsoon's shifting pulse. Water's memory in soils is not only about abundance or absence. Even the chemistry of soil can preserve its story. Ratios of oxygen isotopes in soil carbonates reflect the source and intensity of rainfall, offering a fine dot-grained record of precipitation. By analyzing these subtle markers, scientists can reconstruct past climates with astonishing precision. Soil does not merely recall that it was once wet or dry, it remembers the very character of the rains that passed through it. The Andes provide another vivid case. Here the Inca and their predecessors built terraces that turned steep slopes into fields, carefully channeling water to feed their crops. Archaeologists studying Andean soils find horizons enriched by irrigation and management, but they also uncover traces of drought, hardened crusts, mineral salts, horizons that whisper of scarcity. Even the most advanced agricultural systems, soils remind us, depended on water's reliability and carried within them the record of both success and struggle. Closer to modern times, soils across the American Midwest still bear the scars of the Dust Bowl of the 1930s. Years of drought, worsened by unsustainable farming practices, left the land brittle and exposed. Winds carried away topsoil, depositing fine layers of dust across the plains. Today, soil profiles still show the evidence: truncated horizons, diminished organic matter, and faint layers of airborne silt that mark the years when fields quite literally blew away. These traces are more than memories. They are warnings etched into the land, reminders of how human choices and water's absence can combine to reshape entire regions. Even volcanic soils preserve water's memory. After eruptions, rains transform loose ash into destructive lahars fast, moving mudflows that bury valleys and farmland beneath thick layers. Over time, these deposits harden into distinct horizons, sharp lines in the soil's record where water and fire collided. These layers often coincide with disruptions in human settlement, evidence written in both the archaeology of ruined villages and the land itself. What makes water's memory in soil so profound is its intimate connection to human survival. Civilizations have always depended on fertile floodplains, reliable irrigation, and predictable rainfall. When water behaved, societies thrived. When it shifted, soils captured the evidence of adaptation, collapse, or migration. Beneath ancient Mesopotamian cities, Mayan temples, and Incan terraces, soils still bear witness to this fragile balance. Modern science continues to listen. Soil cores from floodplains reveal the frequency of ancient floods, helping today's river cities prepare for risks. Salts preserved in arid soils map the severity of long-ago droughts, offering perspective on the challenges climate change may bring. By reading water's memory in the soil, we gain a long-term view of rhythms far older than written history. And there is a poetic truth here as well. Water itself is fleeting, slipping through our fingers, rising as vapor, dissolving into clouds, falling again as rain, and moving on. But soil holds what water cannot. Where rivers flow and vanish, where storms pass and fade, soil remains, patient and grounded. It gathers the traces of water's passage, transforming something ephemeral into something enduring. Floods that roared centuries ago are still visible in buried sediment layers. Droughts that withered crops 1,000 years past are still etched in hardened crusts of minerals. Even when rivers change course or civilizations fade, the soil remembers, carrying the memory of water's generosity and withholding in silence. The memory of water in soil is both scientific record and human story. It tells of floods that nourished crops and sustained kingdoms, of droughts that tested societies to their limits, of the delicate dance between abundance and scarcity. To walk along a riverbank or across a dry plain is to tread upon that evidence, the silent archive of water's ancient journeys written in the very ground beneath your feet. Soil ensures that the voices of rains, rivers, floods, and droughts are never entirely lost. But the soil's memory does not stop with the distant past. It is writing still, keeping track of the present, layering the story of our own age into its horizons. Geologists increasingly speak of the Anthropocene, a proposed epoch in which human activity has become the dominant force shaping Earth's systems. Though the exact boundaries are debated, there is no doubt that soil already bears the unmistakable marks of our presence. From plastics to pesticides, from radioactive fallout to heavy metals, our fingerprints are pressed into the Earth itself. Future scientists will one day read these traces as clearly as we now read the ashes of ancient volcanoes or the pollen of vanished forests. One of the most striking markers of our time is plastic. Once hailed as a miracle of modern life, synthetic polymers have infiltrated nearly every environment on Earth. Tiny fragments, known as microplastics, are now turning up in soils worldwide. They are carried by wind, scattered by water, spread through fertilizers, and even delivered by rainfall. Farmers unintentionally plow them into their fields. Rainstorms wash them into riverbanks. Researchers have found them in mountain meadows and even in the remote soils of Antarctica. Unlike organic matter, which decays and cycles back into the earth, plastics persist for centuries, perhaps millennia. In the layered diary of soil, these fragments will stand out as sharp markers of the Anthropocene. Just as layers of volcanic ash help archaeologists date eruptions, layers peppered with plastic will one day identify the 21st century with clarity. Chemicals, too, are leaving an indelible mark. Modern agriculture has relied heavily on synthetic fertilizers and pesticides, altering soil chemistry on a planetary scale. Elevated levels of nitrogen and phosphorus far above natural background levels are being etched into soils everywhere. These surpluses nourish algal blooms in waterways, but underground they alter microbial communities and rewrite the cycles of nutrients. Unlike the slow enrichment of floodplains in ancient times, modern soils remember sudden artificial surges of nutrients, chemical fingerprints of industrial farming. Heavy metals also testify to our presence. Lead from gasoline and paint, mercury from mining, cadmium from industry. These pollutants have settled into soils in vast amounts. In cities, urban soils often contain high concentrations of these elements, silent witnesses to decades of emissions and waste. Even as leaded fuels and paints have been phased out, their legacy endures beneath playgrounds, streets, and gardens. Soil does not forgive and forget. It stores these metals, holding on to them as evidence of human industry. In some places, the levels remain high enough to threaten health, a toxic memory that continues to shape daily life. Perhaps the clearest global marker of the Anthropocene comes from the atomic age. Beginning in the mid-20th century, nuclear weapons testing released a rain of radioactive isotopes into the atmosphere. Cesium-137, plutonium-239, and others settled back to Earth, embedding themselves in soils across every continent. Their appearance is sudden, global, and precise. Dig into soils laid down in the 1950s, and you will almost certainly find them, a radioactive bookmark signaling humanity's arrival as a planetary force. Unlike pollen or charcoal, these isotopes are not natural products of climate or fire. They are uniquely human, unmistakable evidence of our technological age. Many scientists argue that these isotopes provide the sharpest boundary of all for the beginning of the Anthropocene. The soil's memory of our age is not only chemical, it is also physical. Human reshaping of landscapes has left layers as distinctive as any natural process. Vast tracts of land have been ploughed for agriculture, terraced for farming, mined for minerals and paved for cities. Urban soils contain strata of brick dust, concrete fragments, glass shards and industrial residue. Even in abandoned settlements, these artificial layers persist, telling the story of human construction and departure. Open, pit mines, landfills, reservoirs and roadbeds all leave their mark, forming soil profiles shaped as much by bulldozers as by rainfall. So pronounced are these changes that scientists have given them a name: technosoils. These are soils whose properties are dominated not by natural processes but by human-made materials, rubble, slag, plastics, ash and chemicals. They are unmistakable products of the Anthropocene, artifacts of our species written directly into the ground. And another unmistakable sign of our influence lies in the global spread of species. For as humans have carried plants and animals across continents, soils have absorbed their traces. Non-native grasses leave pollen where they never grew before. Livestock compact soils and alter their chemistry. Invasive earthworms reshape soil horizons in places they did not once exist. The soil records these exchanges, preserving evidence of ecological mingling that reflects the interconnected, globalized age we live in. The ground beneath us is no longer only a diary of glaciers, floods, and forests. It is also a record of highways and smokestacks, plastics and pesticides, nuclear fire, and industrial sprawl. Soil is writing the story of our time even now, and as it always has, it will remember patiently, unhurried, alive. Earthworms introduced to North America from Europe, for example, have transformed entire forest soils. They consume the leaf litter that once blanketed the ground, stripping away the protective cover and altering nutrient cycles that trees and understory plants have depended on for millennia. Soil microbial communities also shift when invasive plants take root, changing the underground ecosystem in subtle but enduring ways. In this sense, even the living memory of soil, its bacteria, fungi, and tiny invertebrates, is being rewritten by human movement and trade. These biological changes, though less visible than layers of plastic or traces of radiation, will persist in the record. They remind us that the Anthropocene is not only a story of chemistry pressed into the ground, but also of biology quietly restructured beneath our feet. Future archaeologists and geologists will find these soils both fascinating and troubling. They will read the sudden rise of pollutants, the spread of synthetic materials, and the unmistakable signatures of nuclear isotopes. They will see the evidence of urban expansion, industrial farming, and global trade written as stark interruptions in the patient rhythms of the earth. Compared to the slow transformations of past epochs, the Anthropocene will stand out as a time of abrupt shifts compressed into only a few human generations. To those future eyes, the soil record may look less like a gradual diary and more like a bold, erratic scroll stretched across the planet. It is tempting to see this only as a grim story, yet there are hopeful chapters as well. Soils can be restored, and in some places they already are. Organic farming, regenerative practices, and rewilding projects are enriching soils rather than depleting them. Efforts to reduce plastic use, to clean contaminated lands, and to draw carbon back into the earth will also leave their own signatures in the record. If future readers of soil remember us for pollution, perhaps they will also remember us for recovery, for choosing to heal the very ground that sustains us. Soil is forgiving if given the chance. Its memory, while long, is not entirely inflexible. There is a striking poetry in realizing that our everyday actions are now being etched into the earth, a plastic wrapper carried by the wind, a plume of smoke from a factory, a nuclear test in the desert, a farm field spread with synthetic fertilizer. All of these have left marks that will outlast us. Soil is patient, impartial, and precise. It does not care whether our legacy is admirable or reckless. It simply records the Anthropocene is still unfolding, and its story is still being written. Yet the ground beneath us already holds the first chapters, layered in microplastics, heavy metals, and radioactive particles. One day those chapters will be read by others, perhaps by scientists, perhaps by our descendants, perhaps by beings we cannot yet imagine. And what they will see is that soil has always remembered faithfully. Long after cities have crumbled, industries have quieted, and the people themselves have passed, the ground will continue to carry the memory of our age. Beneath every field, meadow, and forest floor lies an archive even more astonishing than fossils or charcoal. Hidden in the soil is a vast collection of seeds. Tiny packages of life have fallen year after year, generation after generation, and slipped quietly into the ground. Many never sprout right away. Instead, they wait tucked into darkness, suspended between past and future. This underground seed bank is one of the soil's most remarkable memories, storing the potential of ecosystems long vanished and carrying them forward for centuries, sometimes even millennia. Seeds are built for endurance. Each one is a miniature time capsule containing an embryo and a store of nutrients wrapped in a protective coat. Some germinate quickly when conditions are right, but others are designed for patience. They can remain dormant through drought, flood, fire, or grazing, awakening only when the balance of light, temperature, and moisture aligns. At first, this strategy may seem wasteful. Why scatter countless seeds that may never sprout? But dormancy is a hedge against uncertainty, a way of spreading survival across generations. By lying in wait, seeds ensure that life persists even when surface conditions swing dramatically between abundance and scarcity. Soil seed banks vary enormously. In a single square meter of fertile meadow soil, tens of thousands of viable seeds may rest quietly, representing dozens or even hundreds of plant species. Forest soils often hold fewer, but still maintain reserves that regenerate vegetation after storms, fire, or human disturbance. Wetlands, deserts, and tundra all harbor their own hidden collections, each one tailored to the rhythms of their environment. These seed banks form a genetic library buried beneath our feet, a library that ecosystems can draw upon in times of need. Some seeds defy even our sense of time. The seeds of lotus plants have been found viable after more than 1,000 years in dry lake beds. In Israel, a date palm seed recovered from a 2,000-year-old archaeological site was successfully germinated in the early 21st century, producing a living descendant of trees that once shaded ancient settlements. In Arctic tundra soils, seeds preserved in permafrost for tens of thousands of years have been coaxed back into growth by modern scientists. Each example reminds us that soil is not merely a graveyard of fallen plants, but also a vault of possibilities, carrying life across centuries of change. The ground beneath us is no longer only a diary of glaciers, floods, and forests. It is also a record of highways and smokestacks, plastics and pesticides, nuclear fire and industrial sprawl. Soil is writing the story of our time even now, and as it always has, it remembers patiently, unhurried, alive. Even the living fabric of soil is shifting under our hands. Earthworms carried across oceans, uninvited, have transformed whole forests, eating away the leaf litter that once softened the ground, rewriting the chemistry of roots and rivers. Invisible armies of bacteria and fungi rearrange themselves as invasive plants settle in, stitching new patterns into the underground. These changes are quieter than plastics or radiation, but they too linger, whispered adjustments to the living memory of the earth. And one day, when others dig down, they will see what we have written here. They will see the sharp edges of our time, the rise of pollutants, the scattering of synthetic matter, the signature of nuclear isotopes. They will see cities pressed into the ground, farming carved into the soil's chemistry, the trade of seeds and species etched into the smallest grains. Compared to the slow patience of other ages, the Anthropocene will stand out like a sudden jolt of ink, an era of abrupt shifts and restless hands, packed into just a few decades. It would be easy to think this is only a grim tale, yet soils can be healed, and in places, they already are. There are farms that choose to give back more than they take, fields where roots sink deep and replenish what was lost, wetlands being flooded, forests being allowed to return. These too will be remembered. The soil is long in patience, but not inflexible. It does not hold grudges. It simply keeps what is given. If we offer healing, it will record that too. There is a strange, sleepy poetry in realizing that our every gesture is being set into the ground, a wrapper carried by the wind, a cloud of smoke from a chimney, a seed falling unnoticed at the edge of a field. These things slip beneath us, settling into silence. Soil does not care whether they are careless or kind. It does not hurry to judge. It only remembers. And beneath that remembering, hidden in the quiet dark, lies an archive more astonishing than fossils or charcoal. The soil is filled with seeds, tiny waiting lives that fall year after year, century after century, and slide gently into the earth. Most do not rise right away. They rest. They sleep. They wait in their small husks of patience, suspended between past and future. This underground seed bank is a vault of possibility. A meadow can hold tens of thousands of seeds in a single square of ground, each one carrying its own little dream. Some will sprout with the first rain. Others will sleep for decades, even centuries, waiting for just the right light, the right warmth, the right chance. Some of these sleepers are almost mythical in their endurance. The seeds of lotus plants have stirred to life after more than 1,000 years of silence. A date palm seed, sealed in the dust of a 2,000 old settlement, sprouted when touched by modern hands, carrying into the present the shade of ancient groves. In the frozen soils of the Arctic, seeds cradled in permafrost for tens of thousands of years have been coaxed awake, their green shoots trembling like ghosts returning. It is not only survival, it is memory. The seed bank is the soil's gentlest way of remembering what once was. In old farm fields, seeds of wild flowers still sleep, waiting for ploughs to fall silent. In drained wetlands, cattails and reeds lie hidden, waiting for the water to return. Even in deserts, seeds bide their time, patient as stone, until a rare rain spills across the sand and calls them upward. The soil, then, is not only a diary of glaciers, rivers, and civilizations. It is also a cradle of possibility, a quiet library of futures not yet written. It remembers in two directions at once, backward into the depths of time and forward into the yet or .com. And if you lean down, if you listen softly, slowly enough, you might almost hear it. Beneath your feet, in the hush of the ground, the earth is dreaming. Every grain of soil is like a sentence, and every horizon beneath us a chapter. In its particles, worlds meet, geological, biological, human, and more. Soil is an autobiography without a single author, a chorus written by glaciers, roots, winds, ashes, seeds, and footsteps. It is memory made physical, the earth's recollections scattered in fragments too small to notice, until we kneel, until we pause, until we finally pay attention. Soil carries a paradox, a tender contradiction. It is immensely fragile, so easily exhausted, washed away, forgotten. A single storm can strip away what took centuries to form, and yet it is also enduring, patient beyond imagination. Layers buried in silence persist for tens of thousands of years, intact diaries of vanished landscapes, sealed memories of forests and fires. This fragility, paired with longevity, makes soil profoundly poetic. It reminds us that the most essential foundations of life are also the most precarious. Poets and philosophers have long intuited this truth. Virgil, in his Georgics, spoke of the farmer's hand working with the earth as though in conversation with a being generous yet capricious. In ancient Chinese traditions, the element of earth was honored as one of the 5 great phases, embodying nourishment, stability, rootedness. Across indigenous traditions, soil has been remembered as mother, as ancestor, as spirit, alive, sustaining, remembering. These are not idle metaphors. They arise because soil is not only matter but meaning. It is not just ground, but story. Consider burial. When we return bodies to the earth, the act is not merely practical, it is ritual, symbolic of continuity. Soil accepts us at the end, just as it nurtures us through life. It enfolds our bones, our ashes, our final breath into its layers. In this way, soil is not only the preserver of natural history, it preserves human history as well. It is the last page of every story written not in ink, but in loam. There is a quiet democracy in this. Soil receives everything without hierarchy. The fallen leaf, the beetle, the emperor, the poet, all are folded into the same ground. Distinctions blur, but essences endure. Soil is the equalizer and the conserver, blending differences into a single patient memory. At the same time, soil is not isolated. The ground beneath your feet is not only local, it is linked to rivers, winds, skies, and oceans. Dust can rise from one continent and settle on another, enriching soils thousands of miles away. Charcoal from an ancient fire may mingle with pollen from distant forests. To hold a pinch of earth is to hold the planet in miniature, a cosmopolitan handful of whispers gathered from faraway places. Yet soil does not tell its stories loudly. It does not shout. It does not argue. It murmurs softly in horizons, in the smell of rain, in tiny grains of phosphorus, in the pollen of vanished plants. Reading soil requires patience. It asks us to slow down, to listen differently, to learn the language of silence. Its memory is quiet but unyielding. It reminds us that not all truths are loud, and not all memory is visible. Soil also stretches our sense of time. Human memory is short, decades, centuries if we are fortunate. Soil remembers in scales that dwarf us. It carries echoes of ice ages, the fingerprints of fire long before our ancestors walked upright, the DNA of animals whose names we will never know. To kneel beside soil is to touch a story far older than us, far longer than us. We are guests passing through its patient chronology. And yet soil looks forward as well as backward. Seeds buried deep may wait centuries for their chance to rise. Microbes shift and adapt to prepare for conditions not yet present. Ancient human practices, from terra preta in the Amazon to regenerative farming today, have shown that soil can carry deliberate legacies forward. It is not just a diary of what has been, but also a notebook of what may yet be written. The soil even speaks to us through our senses. The damp, rich scent after rain, petrichor, is a kind of sensory memory, microbial whispers released into the air. The feel of earth crumbling between our fingers reminds us that memory is not abstract. It is physical, textured, fragrant, something to be touched and lived. And now, in our age, soil has become a mirror. Plastics, pesticides, isotopes, and smoke are being pressed into its layers. The Anthropocene writes itself beneath our feet. Future generations will read these marks as clearly as we read volcanic ash or glacial flour. Soil does not judge. It records. It remembers abundance and ruin alike. Yet there is hope in its patience. Abandoned fields bloom again, wounded ground can heal, carbon can be welcomed back into fertile earth. Soil forgives if we give it care. Its memory, while long, is not inflexible. We can still inscribe a gentler chapter. To stand upon the earth is to stand upon memory. To walk across a field is to tread upon countless stories, countless endings folded gently into beginnings. Soil is fragile, enduring, silent, eloquent all at once. It is poetry written in particles, a living testament connecting past, present, and future. To call soil poetic is not a romantic gesture, it is simply to acknowledge its depth. It is the humblest of substances, and yet the grandest of archives. It clings to boots, crumbles between fingers, collects beneath fingernails, and still within those grains lies the memory of vanished forests, of vanished rivers, of worlds long gone. To appreciate soil is to practice humility, to remember that beneath every step lies a story far greater than our own, a memory of Earth itself, fragile and enduring, quietly keeping watch as time drifts onward. For soil is never inert, though it appears quiet, a passive surface upon which life plays out. In truth, it is alive with memory. It is constantly writing, rewriting, and storing the stories of Earth. It is a living archive, one that does not rest, one that dreams even while we sleep. To end a journey through its many forms of remembrance is to recognize soil not only as a witness to the past, but as a participant in the present and as a custodian of the future. Its memory is vast, sprawling, intricate. It holds the chemical traces of ancient rains and droughts, the pollen of forests that no longer wave in the wind, and the DNA of mammoths, bison, and countless creatures now gone. It remembers fires in flecks of charcoal, volcanic eruptions in pale layers of ash, human settlement in phosphorus, in pottery shards, in seeds once discarded beside a hearth. Each horizon is a page, each stratum a chapter written in the handwriting of time itself. This memory is not static. It shifts, it builds, it erodes, it layers, and yet it is rarely erased completely. Echoes persist, shadows of what has been carried forward, blending with what is now. Soil is not merely a container, it is alive in the most literal sense. Within a single handful swarm billions of microbes weaving invisible networks of exchange. Fungi stretch like threads of memory, linking root to root across an entire forest. Seeds lie buried, dormant but not forgotten, waiting centuries if necessary for the moment when conditions align and they may rise again. This living component is memory as potential. It is renewal encoded into the earth itself. When a meadow blooms after decades of neglect, when a forest regrows after fire, it is the soil's memory that makes recovery possible. Soil does not only remember the past, it actively shapes the present. Our very civilization has been built upon this truth. Agriculture, the foundation of settled life, depends entirely upon soil's patient ability to nurture and sustain. Cities rise where floodplains once welcomed fertile crops. Empires flourish or falter, depending on how they treat the earth beneath them. The memory of overdot farming, of erosion, of exhaustion, is etched into soils as surely as the memory of abundance. To walk any landscape is to walk on choices made long before, choices remembered and carried into the present by the ground itself. But soil also carries into the future. Hidden seed banks lie beneath the surface like sleeping libraries. Microbial communities adapt, storing resilience for changes not yet here. Even damaged soils retain a memory of what once grew, a potential for rebirth that waits in silence. In this way, soil is not only a book of history, it is a book of possibility. And now, in the Anthropocene, soil, has also become a mirror. Plastics, pesticides, heavy metals, radioactive isotopes, all are pressed into its layers, where they will endure for millennia. Soil remembers impartially. It records our brilliance and our recklessness alike, and in that impartiality, it offers us a chance to reflect. If the ground beneath us is already remembering what we do, then we have the choice to decide what kind of story we will leave written there. Soil will not choose for us, but it will preserve our choices. There is humility in this recognition. The earth beneath our feet is not only foundation, but partner. It holds memory more faithfully than we ever could. Our histories are fragile, lost to fire, flood, forgetfulness. Soil is more patient. It holds on. In its patience there is wisdom, the same wisdom that poets, farmers, philosophers, and elders across cultures have always intuited, to return to the soil at life's end, to call it mother, to treat it as sacred. The science of soil does not diminish this truth. It deepens it. Microbes recycling the past, seeds lying in wait, isotopes preserving the history of the skies, all affirm that soil is indeed memory embodied, the meeting place of decay and renewal, the threshold between death and life. And so to close this journey is not to close a book, but to recognize that the book continues beneath you. Even now, in this very moment, soil is recording today's rainfall, today's footprints, today's pollen drifting in the air. It will carry those traces forward, layering them quietly among countless others. Someday, perhaps thousands of years from now, someone may uncover them and know that you once walked here, that life once thrived here, that this moment mattered. Soil is fragile, yes, easily stripped by erosion, by carelessness, by neglect, but it is also enduring, capable of preserving the voices of climates, creatures and cultures long past. To see it as living memory is to recognize ourselves as part of a longer story, one in which every harvest, every footprint, every gesture leaves a trace. The living soil beneath us is not only history written quietly in layers, it is also future, unwritten and waiting. It is silence, and it is song. It is memory, and it dreams. It is the present moment buzzing with life, and it is a future waiting patiently for its chance. It is archive, witness, and promise, and in that layered identity lies something profoundly comforting. The earth remembers not in words or monuments, but in loam and clay, in charcoal and seed, in the enduring memory beneath our feet. Soil is not simply the ground we walk upon, nor only the medium that nourishes roots. It is something far greater, a vast and patient memory. Within its layers lie the traces of rain and drought, the residues of fire and flood, the pollen of vanished forests, the DNA of animals no longer alive, and the seeds of plants still waiting to awaken. It is both archive and witness, carrying the weight of human footprints as well as the marks of glaciers, volcanoes, and the long passage of time. To look at soil closely is to see that it remembers without judgment. It keeps the story of abundance alongside the story of loss, the legacies of civilizations alongside the whispers of microbes. It holds myths, symbols, and rituals as surely as it holds isotopes and minerals. It is fragile enough to be stripped away in a single storm, and yet enduring enough to preserve voices from millennia past. And as this journey through soil's hidden memory draws to a close, one truth lingers: the ground is not inert. It is alive, layered, and ongoing. It remembers the past, it shapes the present, and it carries within it the possibility of countless futures. Beneath our feet, the story of Earth is still being written, quietly, patiently, grain by grain. And perhaps the most calming reminder of all is this: while human lives rush forward in fleeting spans of years, the soil endures. It holds steady. It keeps the world's memory safe. To stand on the earth is to stand on history, to stand in the present, and to add a line to the story that will continue long after we are gone. To walk upon the ground is to walk upon time itself. To listen closely is to hear the hush of soil and the earth dreaming.